Hey there, folks. In this video, we're going to be looking at pages 57A and B. These are the second two pages, if you will, in the circles packet in case this is a different semester. And I'm starting off with number 19 here. Okay, here I got the angle outside the circle. So I know the angle is equal to 1/2 the difference of the two arcs. So 1/16 minus what I'm going to call x. So distribute that in. That gives me 58. That gives me 1/2 x. Subtract 58. I get negative 28 equals negative 1/2 x. Multiply by negative 2. I get 56 is the length of, is the measure of that arc. Down here, okay, what we need to remember is that a radius drawn to a point of tangency forms a right angle. Another trick that we need to remember is that every radius is congruent, okay, within the same circle. So if from here to here is 9, that means from here to here is 9. So in all together, that's 15. I'm going to generically call this x, and I'm ready to roll. X squared plus 9 squared equals 15 squared. Squared plus 81 equals 225. Subtract 81 from both sides. I get x squared equals 144. And I know that x is the square root of 144, which is 12. In number 23, they tell me that the radius here is 3.2, but I need all the way across in this problem. So that means this is 3.2, so the whole thing is 6.4 units long. So referring to that side as x, this is my right angle, so I know what is going to be c in my Pythagorean theorem. So I get x squared plus 6.4 squared equals 8 squared. So x squared plus 40.96 equals 64. If we subtract 40.96 from both sides, I get x squared equals 23.04. So x is whatever the square root of 23.04 happens to be. And in this case, it's about 4.8. 25, different style problem here. Okay, we have two tangents drawn from the same point outside a circle. When that happens, the two segments have the same length. So they are equal. So subtract x from both sides. So I get x minus 4 equals 7. Add 4 to both sides. I get x equals 11. I enjoy these problems. They're pretty straightforward. Okay. And now, on to page B. Okay. Don't let this fool you. You do not need this length. These are the tangents. These are what are congruent. So set them equal to each other. Okay, I'm going to subtract 3x from both sides. So I get x plus 4 equals 14. Okay, if I subtract 4 from both sides, okay, I find out that x equals 10. Coming down here, okay, these are my length of an arc. So I know it's a fraction of a circle. Okay, and length deals with circumference. So cherry pie delicious. Okay, so circumference is pi times diameter. And diameter, if you remember, is 2 times the radius. So that's what we're going to be operating with. So in this case, I got 315 over 360 times pi times 2 times the radius, which is 12. So this is where it's time to get out the calculator. So 315 divided by 360, leaving out pi, times 24. That gives me okay. I accidentally typed in 24. It should have been 12. So let's cheat a little bit here. Maybe they come back. 12. There we go. I knew there was an issue with with what I was typing. So that gives me 21. I did not include the pi, so that needs to still be there. In this case, it is feet. Next problem, it is 90 as the angle measure over 360 times pi times 2 times the radius. So, this out so there's no confusion. So, 90 divided by 360. Times 2 times 18. It is 9. So 9 pi centimeters. Okay, these are area down here. So x over 360, so the measure of 360 times area, apple pi R2. Apple, area, pi, R2. There's my formula. Okay, so 300 over 360 times pi times the radius squared. So 300 divided by 360 times 10 squared. It's a fraction, so put my fraction button. And that gave me 250 over 3. And then pi, just leaving it as is. And because it's area, it's square centimeters. Last problem, we got 90 over 360 times pi times the radius squared. So, clearing this out, 90 over 360 times 16 squared tells me it's 64. And then pi, and then because it's area, it's square feet. Okay, that's all for this page. Look for the next video to continue on with your review.